Here it comes our last example for this series of examples. I want to pick 4 of my 14 students and I want to send them to talk to the IB coordinator. So this situation is similar to the one we had before in the sense, well, I have 14 students and I want to pick 4 of them. But before, I wanted to pick 4 of them and I wanted to arrange them on a line. Here the students are not lining up, they're just going to leave the class, 4 of them, and they're going to go 1 floor down to the IB office and they're going to talk to the coordinator. And there's no line, so I don't care about the order. That's the first thing that we need to notice here. The order is not important. I just want 4 of my students. So let me call this in the numbers of ways I can pick 4 out of my 14 students. This letter C that stands for combinations. So combinations are just how many ways? Well, let me say it again. Let me say, in how many ways can I pick 4 objects out of a collection of 14 of them? So I wrote C14-4. You will see this also written like in a calculator, 14C4, or even this is also a very used notation, and a bit I'm going to use it a lot too when we don't need to repeat the word combinations of the letter C so often because we are used to it. Big brackets, 14 on top, 4 on the bottom. So combinations of 14 objects taken 4 at a time. We're trying to find what that number is. And we don't know yet, but we have a notation for it. And my reasoning is going to go the way of trying to compare this number and the number we found before that was permutations was 4 element takes out to 14. So let's make clear here that when I'm talking about the permutation, order matters. And when I'm talking about combinations, the order doesn't matter. Order doesn't matter. So we want to see how those two numbers are related, because actually the second one, the one with the permutations, we already figured out how to find it. So let's say I pick my 4 students, and then that will be the combinations we have over here. And then once I have the 4 of them, I can rearrange them, if I care about it, in a line. So I can permute the order between them. So I can rearrange them in different ways. If I do that, well, to do that, I'm going to need to find what is 4 factorial, so in how many ways I can rearrange 4 objects. If I do that, I first pick the objects and then I rearrange them. Actually, I'm going to be getting the permutations. So I don't know what the combinations of 4 objects taken out of 14 is, but if I multiply it by 4 factorial to see all the possible orders, then I'm going to get the permutations. And we know how to find that. So that means from here we can isolate what is combinations of 4 taking 14 at a time. And this is going to be the permutations divided by 4 factorial. And actually for the permutations, we have a formula for this. We have that this is 14 factorial over, and then we're going to have 14 minus 4 factorial. And then we have this 4 factorial also multiplying in the denominator. So this is the formula to find in how many ways I can pick 4 of my 14 students to go to talk to the IB coordinator. And let's go to the calculator and see how much this is. Again, we can go to menu and probability and combinations. And there we go. We have the NCR number. The N is the number of objects, 14 for us. The R is how many we are taking at a time, 4 for us. And the result is 1001. And we can check then 1001 times 4 factorial, so 4 times 3 times 2, so 24. That is the 24,024 we had for the permutations. So right here the result, this was, we can select the students in 1001 ways. And more in general, we can write that if we are talking about permutations of n objects taking r at a time, we need to find n factorial undivided by n minus r factorial. And these are the permutation, and here there is order. Always remember, permutation means changing the order, so there is order there. And if we are talking about combinations, so we have n objects and we are picking r at a time, then in this case, following the formula we found above, well, generalizing it, we have n factorial over n minus r factorial times r factorial. And here there is no order. We just care about the selection of the objects and we don't arrange them in any special way.